Live. Let me confirm that live from my laptop. Okay, and then we'll begin. YouTube.com. Okay, I'm sorry. Yeah, live solving. I think it's working. Oh, but maybe I should tilt my device, I guess. Sorry for the noise. Maybe I should tilt my device, I guess. Sorry for the noise. So is it fine now? What do you say? Is there anyone on the chat? Is anyone watching? Let me invite a few of my friends. Hi, live has started. Okay. I'll just wait for one of my friend who is basically preparing for integration B. So I believe he would want to join. And then once he's there, we'll start. We'll start. Yeah, I guess he's the hello sir. Okay, yeah. So let us start. The MIT integration between 25. Oh wait, let me. Okay, I'm sorry. There was echo. I think there's no echo right now, right? Can you confirm that there's no echo right now? Is it fine now? Suzo? Yeah, okay. Let's go ahead then. Okay, so we are doing the MIT integration between 2025 regular season, right? There are basically 4 seasons: regular, quarterfinal, semi-final, final. So yeah, let's begin. Yeah, MIT integration B regular season. The limits for is integral. Time limit is just 2 minutes, but yeah, we'll take as much as we want. This is the first problem. Integral from 0 to infinity dx divided by x plus 1 plus 2 root x. I think this one shouldn't be too hard. Even I have not done any of these integrals. This is the first time even I'm doing, right? So, like we will just go together. I think this should not be too hard because this is a regular season. But let's see how it goes. If we are stuck, we'll definitely discuss and then do, right? So, what do you think should be our approach, Sujal? Like, how would you approach this integral? Like, how do you think? Like, anyone can, not just Sujal. There are four of us who are watching. Anyone can suggest, like, how do you think we can approach the integral? Yeah, well, let's do that. The thing is, over here, if you we can actually make it a complete square, right? This is root x square plus 2 root x plus 1 square, right? So this becomes integral from 0 to infinity dx divided by square root plus, okay, so this is the inside is just square of root x plus 1, right? And again there's a square because a plus b whole square is basically a square plus 2a plus b square. So this becomes dx divided by root x plus 1 to the power 4, right? Now I can make the use substitution just like you said. So if I make y is equals to root x, I will basically have y square is equals to x, right? And then if I differentiate both sides, that will be 2y dy is equals to dx. So now if I make y is equals to root x substitution, now the limits will go from root of 0 is 0, root of infinity is infinity, dx is now 2y dy divided by root x is y plus 1 to the power 4. Now what do we do, Sujal? Like what do you think how should we proceed ahead now? What's your idea? Hmm? No idea. Okay. Okay, let me give you a hint. Like, what you can do is, you can try to break this single fraction into two different fractions. How will you do that? Ye- ye- yeah, that's how you can do it. You can actually make a substitution again. Or what you can also do is, that's the same thing though, but um, you can also make the y as y plus 1 minus 1, right? So that's the same thing basically as you are saying it. It's no different. But yeah, like you can just break it into two fractions and then you can solve it easily. So now this is now, sorry, power 4. So this is just 1 by y plus 1 to the power 3 minus 1 by y plus 1 to the power 4. And now this is solved, right? This wasn't too hard actually. 2, and now this is just y plus 1 to the power minus 2 by minus 2 minus y plus 1 to the power minus 3 by minus 3, and this goes from 0 to infinity, right? And now over here, infinity to the power negative 2, that goes to 0, minus that also goes to 0, right? Minus, and if substitute 0 over here, that's just 1 by negative 2, minus this is just 1 by negative 3, right? And after this, what we can do is 2 times, that's just 1 by 2, and this is minus minus plus, but again there's a minus outside, so again minus 1 by 3. So this becomes 1 minus 2 by 3, which is basically again 1 by 3. So that should be our answer. So let's check the answer, okay? 1 by 3. And that's the answer. So this was simple, right? What do you think? This was actually not too hard. This was just some use of substitution and we got the solution, right? This was hard, right? Like this was easy, right? What do you say? Let's go to the next one. Okay, next one is problem 2. Uh, the problem 2 is integral from sorry, just integral of, yeah, easy, yeah, x square cos of, sorry, arc cosec x dx, arc cosec x dx. That was it, right? X is equal arc cosine of, okay. So how do you think we should solve this problem? Okay, one of the ideas is we can basically change r cosec x into r cos x, and if we do that, we can cancel the cos in r cos x, right? So please do integration of ln cos x after this. Okay, yeah, of course, we can do that. We can do that. Hmm. And like, is there any like limits of integral, or it's just ln cos x? Or is there any limits, or just this is an indefinite integral? Yeah, you can respond. Okay, but for now, let's do this problem. So we basically want to change r cosec x into r cos x, so that cos and the r cos x will cancel out, right? So what we can do is, first of all, let's make a substitution. Like, I mean, it's not substitution, but we are just trying to change. If we make y as r cosec x, we will get cosec of y is equals to x, right? And now we will get sine of y is equals to 1 by x. So cos of y is equals to square root of 1 minus 1 by x square, right? Cos y is equals to square root of, now this will just be x square minus 1 by x square, so that is just square root of x square minus 1 by x. So that means y is r cos of square root of x square minus 1 by x, right? Okay, so now we see that y, which was r cosec x, is just r cos of square root of x square minus 1 by x, right? So let's use that. Now this integral becomes x square times r cos of square root of x square minus 1 by x dx. So what we did was we just replaced r cosec of the, cos of the r cosec x with r cos of the square root of x square minus 1 by x, right? Oh, sorry, I forgot the cos over here in front of the, yeah. Now just the cos and the r cos, they cancel, they seemingly cancel out. So that gives us x square times, and then, yeah, the following expression, right? And now this just becomes x times square root of x square minus 1 dx. Now if you make substitution that y is x square minus 1, dy will just be 2x dx, right? So x dx now is just dy by 2. That's our x dx. So this becomes integral of the square root of y times x dx is dy by 2. So that is just 1 by 2 times integral of square root of y is y to the power 3 by 2 by 3 by 2 plus c. The 2 cancels out. So this is just 1 by 3 y to the power 3 by 2 plus c. And our y is x square minus 1. So 1 by 3 x square minus 1 to the power 3 by 2 plus c. So that's the answer. Let's check it. Let's check the answer. 1 by 3 x square minus 1 to the power 3 by 2, and that's the solution. This wasn't too hard. Okay, seems like he liked the problem. That's nice. Let's go ahead, right? And like Sujal, I think there's already a video on my channel regarding like ln cos x. Also, there's one by Maths 505. I'm pretty sure. So you can check that. Or also, if there's not, I can make another video. But in this video, let's just do the ambiguous integration problems, okay? Or we can do it at last. Yeah. What do you say? Okay. Now let's go to the next problem. So this was just changing r cosec x to the r cos x, and that gave us a solution. Now problem 3. Problem 3 seems to be a really good problem, I guess. It has integrals, it has sums, right? So let's do this problem. Problem 3 is integral of from 0 to 1 by 2025, sum from k equals to 1 to infinity, 2025x, and what else was there? To the power k e to the power minus 2025x by k factorial. Wow. It looks hard, but it should not be hard, I guess. To the power, what was it? Minus 2025x by k factorial, and then dx over there. So this solution. What do you think? How we should solve this problem? Okay, one thing I notice is there is this e to the power negative 2025x this term over here, which is not actually a function of k. So you can easily take that out from the integral, right? We can easily take that expression out of the integral. No idea too hard. Okay, you can just first of all take this exponential term outside of the sum, because the exponential term is independent of k, right? There is no k in it, so we can take it out. Now I think this sum should be familiar to you. 2025 x to the power k by k factorial. This should be a familiar sum. Now, reason this sum should be familiar is because we know that let's say e to the power theta is just sum from k equals to 0 to infinity of theta to the power k by k factorial. So this is the definition for an exponential function. I mean, e to the power x or e to the power theta or exponential function, right? So if we compare with this, notice that we just here this sum goes from 1 to infinity over this sum over here, and instead of theta there's 25x, right? So basically we just don't have the first term. If there was the first term, this sum would just be e to the power 25x, right? So let's use that. So if we use that, this becomes integral from 0 to 2025 e to the power negative 2025x, and basically the first term is not there. So what we will do is we will write it as e to the power 2025x and subtract the first term, which will basically be 2025x to the power 0, which is 1, by 0 factor is 1. So yeah, basically the first term is just 1. So yeah, that makes sense, right? And after that, this 0 to 1 by 2025, that's just 1 minus e to the power negative 2025x dx. Now, this should not be hard to integrate, right? Integral of 1 is just x minus integral of the other expression is just negative 2025x divided by the coefficient of x, which is negative 2025. This goes from 0 to 1 by 2025. So this is just 1 by 2025 plus, and then that's just e to the power negative 1 by 2025, right? Minus, this is just 0 plus, that's just 1 by 2025. So 1 by 2025 cancels out from both sides. This is just e to the power minus 1 by 2025. That's a pretty nice answer. That's a pretty elegant answer, right? So yeah, this just involves the definition of the exponential function, nothing else. So let's check the answer if it's right or no, wrong. Yeah, exactly, 1 by 2025e. That was exactly what we got, 1 by 2025e. And that was a nice solution, right? Yeah, because even though it looked hard, it wasn't hard. So yeah, that's often the case in like the first round of MIT integration B. So now let's go to another problem. I hope you guys are enjoying the solutions, right? These problems are interesting. Okay, now let's go to this one. Integral of dx by 1 minus x to the power 4. Integral of dx by 1 minus x to the power 4. Okay, now how will you guys approach this problem? Will you just do partial fractions directly, or is there any shortcut other way? What do you think? Do you think there should be an easy way for this integral? What do you think? Like, how will you do this, Sujal? Like, what would be your approach? Is it that partial fractions is the best way? Or okay, so let's go with the partial fractions. This should not be too hard, I guess. Okay. So we know that this is just 1 minus x square, 1 plus x square, right? Now to break this expression, what I can do is I also introduce 1 minus x square plus 1 plus x square numerator, right? And the reason is because the numerator just cancels out to 2, I can just introduce a factor of half, right? So that's the easy way of doing partial fractions. Now, because the numerator was just 2, I introduced half, so that basically cancels out and makes it 1, just like earlier. Now this becomes half times integral of 1 by 1 plus x square plus 1 by 1 minus x square dx, right? Ooh, thanks for giving the love. I appreciate that. And now this is half of, now this is just tan inverse x plus, and this is just 1 by 2 ln of 1 plus x by 1 minus x, right? Plus c. And that's our answer. This wasn't too hard, right? So let's check the answer. And these two are standard formulas, right? I guess you know that because integral of 1 by a square plus x square dx is just 1 by a tan inverse x by a, right? Similarly, plus c 1 by a square minus x square dx. This is just 1 by 2a ln of a plus x by a minus x plus c, right? Okay, so let's take the answers. 1 by 2. Yeah, 1 by 2 tan inverse x plus. Okay, now how do I make sense of this? 1 by 4. Oh, yeah. Yeah. Basically, what they have done is, basically over here, what they have done is, now if I distribute the half to both sides, this will just basically become half tan inverse x plus 1 by 4th. Now this becomes ln of 1 plus x minus 1 by 4th ln of 1 minus x plus c. So that's what they have done, right? Now it exactly matches the answer. Yeah. So now let's go with the next problem. So yeah, integral from negative pi by 2 to pi by 2 cos 20x cos 25x dx. Okay, let's do this one. This is our problem 5. Integral from negative pi by 2 to pi by 2 cos of 20x cos of 25x dx. Now, okay guys, suggest me your apples again. Like what, how do you think? Do you think there's an easier way for this one? Do you think there's some shortcut ways? Hmm. What would be your apples, guys? Yeah, I think I will do the same. But do you think there are some other ways too? No, I guess that's just the way. Let's apply that formula. So what we basically do is uh, we f- uh, we first of all make it look like 2 cos of something again cos of something, right? And after it looks like this, what we do is we basically use the formula of cos. Uh, Basically in the formula of from multiplication to addition, right? So what that does is now this becomes cos of a plus b plus cos of a minus b. Am I right? Yeah. Am I right or am I right? Okay. Now this becomes half minus pi by 2 to pi by 2. Now this just becomes cos of 45x plus cos of 5x, right? Because cos of negative x is again cos of x. So we are using the property that a cos is even function. Half of, now this is just sine 45x by 45 plus sine 5x by 5 from negative pi by 2 to pi by 2, right? So now this shouldn't be too hard. Now sine of 45 pi by 2. Now how will you find its value? So now to find the value of sine of 45 pi by 2, basically you have to check like if okay, so basically 1 will be here, 2 over here, like basically pi by 2 is here, pi is 2 times pi by 2 is here, 3 times pi by 2, 4 times pi by 2, 5 times pi by 2, 6 times pi by 2. Basically these numbers have are in the form 4n plus 1 times pi by 2, right? Basically each term is basically 4 times pi by 2. So again, so 2 pi plus any pi by 2 basically becomes gets in the form of 4n plus 1, and this is in the form of 4n plus 3 pi by 2, right? So over here 45 is basically 44 plus 1, right? So basically like 4 times pi by 2, 8 times pi by 2. So basically 44 times pi by 2 is here. So 45 times pi by 2 basically goes in 90 degrees. So that means this will just be 1 by 45 plus, now sine of 5 pi by 2 again. Sine of 5 pi by 2 again here, because that's in the form of 4 plus 1. Again, just 1 by 5. Right, and remove that to 1 by 45 plus 1 by 5. So there's a 45 over here in denominator. 1 plus 9. So that's just 10 over 45. And that's just 2 over 9. And that's the answer. 2 over 9. I also recommend you guys to solve it like while I'm solving on your own, right? So that you get the feel, right? So the answer is 2 over 9. This wasn't a hard problem. This was actually a really easy problem, just the product formula, right? So let's quickly go to the next problem. Okay, so this one seems to be a good problem, right? What do you guys say? Do you think this is a good problem? From negative 2 to 2, max of x square x cubed. So how will you solve this problem now? Max of x square x cubed dx. What's your approach, Sujal? Or anyone else? Anyone who is watching? What would be your approach? How would you approach this problem? What is max? Okay. Basically, the max is, okay, so let me show you what max is visually. So, let's say, first of all, let me draw the graph. We know that the x is just like a line, right? Let me just also make some coordinates. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 1, sorry, negative 1, negative 2, negative 3, negative 4, right? And so this is basically the graph of y is equals to x. Now x square. Okay, so x square, basically x square. Let me make it slightly more clear in the sense that this should pass through 1 comma 1, 2 comma 2, 3 comma 3, right? So I want to make that clear because we might need that, right? Okay, so this is y equals to x now, and our y equals to x square also passes through the same point, and 2 comma 4, right? 1 comma minus 1, minus 2 comma 4 again, right? So this is our y is equals to x square, and notice that the value of x square is less than y equals to x, while it's less than 1. I guess you know that fact, right? The reason is when you square the numbers less than 1, they become lesser. That's an interesting thing to know, right? Okay, so this is x square, right? Now again, how is x cubed? So basically for 2, this goes to 8, right? X cube goes to 8. But again, the thing is, yeah, it goes like this. Again, it's lesser than the x square, while it's between 1 and 0, right? And yeah, it goes again this way up to minus 1. It meets at minus 1. Again, this blows off. Okay, so these are the graphs, right? This is y equals to x, this is y is equals to x squared, this is y is equals to x cubed, right? Okay, now what max function is? Okay, what is max function now? Okay, what max function is, you can see it this way. So let me plot the max function now from minus 2 to 2. Okay, so now in between minus 2 to 2, let me plot how the max function will behave. So while it is at minus 2, among these three functions, the maximum value is attained by x cube, right? So max function will basically, the curve of max function will basically be in the path of x cube, while it goes from minus 2 to 2 to 1, right? And now, Okay, now like at 1, now among these three functions, y equals to x has the maximum value, right? So now this will take this path. This is the curve of max of x square x cube. Now after this, among these three functions, x square has the maximum value, right? So this will take this curve. So basically this red curve is the curve of y is equals to max of x square x cube. So yeah, the function max x square x cube is denoted by this red curve. Do you get the idea now? What is max function? So this red curve is basically the max of x square x cube. So yeah, that's how we denote this function. Do you get the idea, or is it still unclear? I guess it should be clear now, right? Or is there any doubt? Got it. Oh, okay, that's good. Okay, now we need to find integral from negative to 2, right? Okay, so now let's first see the definition. Like let us first define the max function in a clear way while it goes from negative to 2. So now we saw that this max of x square x cube, this is defined as, while it's from 0 to minus 2, it's just defined as x square, while x is between minus 2 to 0, right? And while it's between 0 to 1, it's just defined as x while it's between 0 to 1, right? And it's just defined as x cube while it's between 1 to 2, right? So this is the definition of max function now. And according to this definition, we'll integrate it. So now we have to integrate from minus 2 to 2, but in different intervals, there are different definitions of this function. So we'll do it part by part. So what we will do is, we will first integrate from negative 2 to 0, and in this case, the function is x squared. Now we'll integrate from 0 to 1. In this case, the function is x. And now we integrate from 1 to 2, and the function is x cubed dx. So even though this looked hard, this wasn't that hard, right? This was actually really easy. You just needed to identify which function is max in which like cases. So yeah, that was nice. So now let's solve it. This is just x cubed by 3 now, going from negative 2 to 0. Plus now this is x squared by 2, going from 0 to 1. And this is x to the power 4 by 4, going from 1 to 2. And now this is just at 0, this is just 0. Minus at negative 2, this is negative 2 cubed by 3. Plus this is just 1 by 2 minus 0. This is just 2 to the power 4 by 4 minus 1 by 4. So now this is 8 over 3 plus half plus 16 by 4 is 4 minus 1 by 4. Now if we add it, this will just become, let us just take the LCM, 12. So 32, 6, 48, 3, right? And now this becomes 48 and 32 is just 80, 86, 83 over 12. So that's our answer. Let's check if our answer is right or wrong. 83 over 12. That's right. And when you get the right answer, it's fun, right? So I hope you like this problem, and also some of you also got to understand something new. And yeah, such problems are also there in integral B, so it's good to know them, right? The max function, also there are other functions like there are g functions, fractional part functions. There are many others, and it's good to know them because they are often asked, right? So let's go to the next one. Exactly I said that there are the fractional part functions and there is. Now this one has a fractional part, right? So let's do this. Let's see what a fractional part is. Okay. So integral from, wait, what was that? Integral from 0 to 2025 fractional part of root x. 0 to 2025 fractional part of root x. Always know that this basically denotes the fractional part function. Fractional part function. Or at least I think that, because it always used to, as long as I know this function, I always thought that this denotes fractional part. Let's see if it denotes, if it is no or not. And basically this denotes the floor function. I should better to know this, like know them, right? And this denotes the ceiling function, right? You can basically Google them. Yeah. Now what fractional part function does is, so I'll just give you a few examples and then it should be hopefully clear. Let's say if I want to find fractional part of 1.2, that's just 0.2. Fractional part of 2.5, that's just 0.5, right? So basically fractional part of n is just n minus floor of n. So in this case, let's say if I want to find fractional part of 2.9, that's just n is 2.9 minus floor of 2.9 is 2, that gives me 0.9. So I guess you get the idea what fractional part is, right? So fractional part is basically just the fractional part. It's obvious from like how I'm saying it. So how do you think we will approach this problem now? What do you guys say? What's your idea, guys? Basically, it's just we will basically use the idea that the fractional part, of n is just n minus the g of n. We will be using this formula. Okay, what should we think we should do first? What should be our first approach? I mean, the first thing that we need to do. So this something we basically want to find out, like when does this function root x takes integer values, right? So let me take you through this. Okay. So first of all, like there's some reason behind this why I'm trying to find out where this root x takes integer value. That's actually important. But let's we will see why that's important. Okay. So should I do that? Yeah, I guess so. So first of all, it takes integer value if x is a square number, right? So basically for 1, for 4, and 9, 16, again for let's say 25, sorry. And there are a lot actually, because it's 20, that's a big number. And then 36, and yeah, up to 25. Now you might notice that, okay, in between these two values, okay, because the over here in this case the root of 4 is 2, right? And root of 1 is 1, right? Root of 9 is 3, right? So in between in these two values we will have 2 point something. Over here we will have 1 point something, right? You get that? Yeah. So now over in between in these two values, our fractional part, like to get the fractional part, what you can do is basically in the between these two values we can just do root x minus 2, right? Over here we can do root x minus 1, right? And between in these two we can do is root x minus 3. Over here we can do root x minus 4. Over here we can do root x minus 5. Are you getting the idea what I'm trying to do? Because over here this will just be 4 point something, right? Because it's between 16 to 25. So yeah, that's our goal. That's the way we will do it. So what do we, okay, I think it's getting clear now how I'm trying to approach the problem. So let us now systematically do it if it's being clear. So 0 to 25, you know that this is just root x minus the floor of root x, right? And I think one thing that I can do is, to make this even more easier, let me just make a u substitution first. If I make a u substitution that u is root x, this will be even more easier. So let me take that approach. If I do u equals root x, I will have u square is equals to x, right? So 2u du is equals to dx, right? And now the limits of integral will now be from 0 to 125. This is just the square of 45, and fractional part of root x is that just becomes u now, and dx becomes 2u du, right? Now this becomes 0 to 45 2u. Now this fractional part of u, that just becomes u minus the floor function of u, right? Now 2 goes outside, and then integral from 0 to 45 u square minus u times fractional part of u du, right? Now what we will do is the first integral is actually easy, right? This is just u cubed by 3 going from 0 to 45. Now for the second one, there's a special technique, right? It's just based on the idea that I told you earlier. What I will do is for the second one, u cubed by 3. Now let me just evaluate this little. I will do it later on. Okay, 0 to 45 minus over here. What you can do is, let me do it. Okay, let me do it by keeping bracket. So what I will do is I will basically write a sum from 0 to 40, 0 to 44, right? And then integrate from I to I plus 1. In the why I can do this is basically this integral from 0 to 1, from 1 to 2, from 2 to 3, from 3 to 4, from 4 to 5. All of these are being summed up. And while we're like adding the integrals, basically the limits will go on adding, and then basically this will just become an integral from 0 to 45, right? And the benefit of doing this is now you will just remain as u, right? But the g of u, while we are integrating in between I to I plus 1, that will just be I. So that's the benefit of doing this approach. So do you see like why I'm doing this approach and like why it's helpful actually? Because from this approach, I can basically express g of u as some integer I. Do you get this idea? Like, or do you need some time to sink it in, or do you want to ask something? This is our like major, like major approach. I mean, this is our major. What do you say? The main the turn away or something like that. Is there any confusion with this? Like what I'm doing right now? After this, it's easy. Like this is the only thing that you need to understand. Oh, got it. Okay, that's nice. That's nice. That's nice. Okay. So if you have got it, so now let us again let me just write this u cubed by 3 from 0 to 45, but too high level. No, not really high level. You just need to get used to with it. Like if you are like doing it frequently, you just get used to with it. What I did was just I just broke these integrals in between 1 to 2, from 2 to 3, 3 to 4, 4 to 5, and all of this. And we know that while it's going from 1 to 2, g is just 1. While going from 2 to 3, g is just 2. From 3 to 4, g is just 4. And u is just as it is. And yeah, it's just a technique. And once you get used to it, like you can apply it anywhere. And there are a lot of problems in like about problems in integration b about this z-fin fractional part, so you need to know it, right? It's important. If you want to win integration b, you need to know this, man. Okay, so now this will just become a sum from I is equals to 0 to 44. Now because I is a constant, I can take that out. And now this just becomes u square by 2, right? From I to I plus 1, right? So now this becomes 2 times u cubed by 3 going from 0 to 45 minus sum from I is equals to 0 to 44 I by 2 times. Now this just becomes I plus 1 square minus I square, right? And then 2 u cubed by 3 going from 0 to 45 minus sum from I is equals to 0 to 44 I over 2. Now I plus 1 square minus I square is just 2I plus 1, right? Okay, so 2. Now it's easy. Now there's nothing more to understand. And then now this is just I is equals to 0 to 44. That's just I square plus I by 2, right? Yeah, I square plus I over 2. 2 times u cubed by 3. 0 to 45 minus. Now this is I plus 1. I guess you know this formula, right? To sum of I square, right? Okay, actually this is n plus 1, not I plus 1. And now n is 44. So 44, 44 plus 1, 44 into 2 plus 1, and n plus 1, 2n plus 1 by 6, right? And yeah, also. And now for I by 2, that's just n into n plus 1 by 2, right? And n is 44. So 44, 44, 44 plus 1 by 2. Also, there's another 2. So do you get it? Do you get this sum? This is not too hard. This is just formulas. I guess you know the formulas. Let me just write it over here if you don't know. Sum of I is basically n times n plus 1 by 2 if it goes from 1 to n. And sum of I square if it goes from 1 to n. That's just n plus 1, 2n plus 1 divided by 6, right? Yeah, now let's solve this problem. Now we definitely need calculator over here. Yeah, so yeah, I wonder how it takes I mean, for people it should, I mean, in integration B that it might have taken a lot of time, but I don't know. So that divided by 3. The first one is just 30375 minus 0, right? Minus, now this one is just, let me just see, 44 into 45 into 89 divided by 6. That's 293770 plus, now this is 44 into 45 over 4. That's 495. Okay, now if you take the difference, whew, this is a lot of calculations. 30375 minus 29370 minus 495. That's 510 times 2 is 1020. That's the answer. Guys, how did you like this problem? Oh, there are a lot of viewers now gone. 1020. Yeah, and that's the answer. And like when you see that your answer matches, there's nothing more like, I mean, joy and happiness than that, right? So did you understand the entire solution, guys? Let's just confirm if you have any doubts anywhere. I mean, this approach, like with this approach, you can do even without integrating. But yeah, this approach is more of a kind formal approach and more of this involves integration, and this made our life easier, right? Yes, do you have anything to ask, or do you have any queries or doubts? Because this was a long solution. Let me know. Let me know before you go to the next problem. Isn't there direct formula? No, no, there isn't. Like every time if you see a fractional part or GIF function, definitely this will always be involved. This thing was like a sum of integral. This will always be there whenever you see a fractional part or GIF. At least that, at least like that, like I have that experience. I mean, every time I see a GIF or a fractional part, I have always seen that like people have been using this. Maybe there are, I don't know, but yeah, this is how people usually do it, by breaking it into a like sums of the integrals, and then we can evaluate the floor function, and that's how people do it. Yeah, so maybe no. I'm not sure, but maybe no. Okay. So is there anything else, or should we go to the next problem now? Is there anything else like that you guys might wanna chat about? Ooh, this is getting interesting. First of all, there was max function, right? And then after that, there was this fractional part function, and now they have the modulus. Wow, wow, it's getting interesting, guys. This is gonna be fun. So integral from 0 to 2 pi, modulus of sine of x plus half of dx. Okay, now again, how are we going to approach this problem? What are your thoughts? Hmm? Hmm? What are your thoughts? Like, what do you think will work in this problem? I think the best way is always to maybe look at visually. Or for this function, basically, the thing is, whenever this inner expression is negative, like we just provide the like I guess you know that fact that like f of x, this modulus of f of x, basically it's just defined as f of x whenever f of x is positive, right? And negative f of x whenever f of x is negative, right? So that's how it's defined, right? So you basically need to see when f of x is when this entire expression is positive and when it is negative, right? So that's our goal actually. So let's just try to see that. So so now how do we do? Okay, so I think the best way is to go visually, I guess, as much as I know, right? So let's just do that. So first of all, we know that this sin x, let's say there's mm, let's say there's this pi by 2, there's a pi where the gap isn't like uniform, pi by 2, pi, 2 pi, 3 pi by 2, right? So basically y of y is equals to sin x will just be this go in there, so 1, there there should be a half, right? And okay, and so basically if this is pi by 3, if this is sorry pi by 6, I guess that's too close again. So there should be a pi by 6 over here, there should be a pi by 3 over here. At pi by 6 is already 1, and yeah, at pi by 2 it becomes 1. Sorry, at pi by 6 it's half, and then again this goes to 0 at pi, the same thing, negative half, negative 1, right? And yeah, again there should be this should be 7 pi by 6, there should be 4 pi by 3, right? 7 pi by 6 it's again negative half, and it attains a value of negative 1 at 3 pi by 2, right? And it goes back, and it again has a value of half over here at uh, 11 pi by 6, and it has value of root 3, I mean root 3, negative root 3 by 2 at 5 pi by 6, sorry 5 pi by, sorry, what's that, 2 pi minus pi by 3 is 5 pi by 3, right? So yeah, if we just need this graph, Now after we are done with this, now notice that what we are trying to do is we are trying to add half to it, right? So if we add half to this, what happens is, now if we add half to the value of sin x, all the possible values that are above this line will turn out to be positive, right? You agree or not? If we add half to sin x, all the basically values, all this path, now all this domain, I should say, I guess. So in all this domain, or whatever you get the idea, the sin x will be positive, right? And only in there over here it will be negative. What do you say? Do you agree or not? Do you agree with me? Do you agree with me? Like in the lower person, again, it's even after adding half, that will still be negative, but the remaining portion will be positive. Is that true? Is that true? Here you have some time. Take your time before before you respond. Yes. Okay. So now if you believe that, now let's integrate this. Now again, let's just let us define this function again. So this sine of x plus half, this is defined as sine of x plus half itself in between 0 to, what is this point? 7 pi by 6, right? Okay, in this range it was positive, so yeah, defined as usual, right? And this was defined as negative of sine x plus half, right? In between 7 pi by 6 to this other point is 11 pi by 6, right? Yeah. And again, this was defined as sine x plus half itself in between 11 pi by 6 to 2 pi, right? And we just needed the definition in between 0 to 2 pi, so we will end up over here in 2 pi. So that's how it's defined. And now after we get the definition, now it's too easy, right? Now this shouldn't be hard at all. This shouldn't be hard at all. I think now everyone can do it, right? So now this will just become 0 to 7 pi by 6 sine x plus half dx plus 7 pi by 6 to 11 pi by 6 negative of sine x plus half dx plus 11 pi by 6 to 2 pi sine x plus half dx. Is that clear? And now I think after this everyone can do it, right? So now this is just some basic integrals that we have been learning since we are a child, since we were a kid. Okay, now integral of sin x is just negative cos x plus x by 2, which goes from 0 to 7 pi by 6, and this is okay. Now integral of negative sin x is just cos x. Integral of negative half is minus x by 2, going from 7 pi by 6 to 11 pi over 6, and this is just negative cos x plus x over 2, going from 11 pi over 6 to 2 pi. Is it working? Like, is it lifing? Is it integrating? I don't know. Like, I was trying to be funny. Okay, now cos of 7 pi by 6. How will you find that? 7 pi by 6 is basically over here, right? This is basically just pi plus pi by 6. So over here, cosine is negative, and at pi by 6, the value of cosine is root 3 by 2, right? Yeah, so that will just be negative root 3 by 2 plus 7 pi by 12, right? So yeah, and then minus at 0, that's just negative 1 plus 0. The first one is done. Plus, second one, at 11 pi by 6. Okay, 11 by 6 is over here. Over here, cosine is positive, and at pi by 6 it's root 3 by 2, so that's just root 3 by 2 minus 11 pi by 12, right? Minus 8 7 pi by 6. Again, 8 7 pi by 6, it's just, we already found it's negative root 3 by 2 minus that 7 pi by 12, right? Yeah? Yeah. Okay. And then plus, now what you can do is, guys, there's actually easier way. You know what? No, I don't know. Let it be what it is. It doesn't matter. Okay. So now let's go with this approach. Doesn't matter. Okay. Now, this is just now that's just negative 1 plus pi minus at 11 pi by 6. That's just root 3 by 2. So negative root 3 by 2 now because of the negative sign. And that's just 11 pi by 12. Whew, that's a lot of calculations. Now, let's just try to open brackets. Root 3 by 2 plus 7 pi by 12 plus 1 plus root 3 by 2 minus 11 pi by 12 plus root 3 by 2 plus 7 pi by 12 minus 1 plus pi plus root 3 by 2 minus 11 pi by 12. Now, there are 3 root 3 by 2's. So 3 root 3 by 2, and there are this negative 1, positive 1 cancels out. There are 2 7 pi by 12. So 14 pi by 12. 2 11 pi by 12. So negative 22 pi by 12. And then there's a plus pi, right? So this is 3 root 3 by 2 plus, if we add pi to 14 pi by 12, that's 26 pi by 12 minus 22 pi by 12. So that's just 3 root 3 by 2 plus 4 pi by 12. And then that's 3 root 3 by 2 plus pi over 3. And that should be the answer. Let's check it. 3 root 3 by 2 plus pi by 3. Whoa, this time we got the wrong answer, guys. Wait. 5 over 3 plus 2 root 3, right? So let us see where we made the mistake. Oh, I see it. Do you see where we made the mistake? There are actually 4 root 3 by 2's, right? There are actually 4 of them. So this should be 4. So this should be 4, right? And if there's a 4 root 3 by 2, that should be 2 root 3, right? 2 root 3. So 2 root 3 plus pi by 3. So how was this problem, guys? Like, did you enjoy this? Like, did you get any new insights for the integration B? Will this be helpful for integration B? I hope yes, right? Do you think you got some new insights, or was it helpful, or like was it easy? Was it interesting? Do you know how much time we should take in this type of question in integration B? Usually like I think a single problem they will give me around 2 to 3 minutes usually, I guess. Around the Okay, in Amid integration B, this was for 2 minutes. You guys might get 2 to 3 minutes, I guess. And it's not necessary that you do all of them. You can just do around like more than half. I don't know. So yeah. Like I think the best way is definitely skip these problems where there are modulus, diff, and come back to them at the end. Like I definitely suggest you to do these problems at the end, because these problems tend to be time consuming, right? Yeah. So definitely. I also in integration B, there are chances you might make numerical mistakes, right? Definitely come to these problems at the end, because there's a lot of risk involved in such problems. Yeah. So let's go to next problem now. Is there anything more? Okay, let's go to this problem. This problem is even more nice. There are two logs. Log. Wow. So this is okay. Wait, what is it? Integral of x half plus log x log x. Okay. Integral of x half plus log x log x dx. Now, how do you plan to approach this one, guys? How do you plan to approach this problem? Hmm? Give me some ideas that you think will work. Factor? Okay, to factor what actually? I mean, where do I factor? Hmm? Can you be more specific, Daniel? Like, hmm, I don't see what you are trying to say me. Oh, okay. Yeah, okay. That's fine. Hi. Okay, do you have any other ideas, guys? Suzal, do you think that? Okay, I don't know. Take your time and try to come up with some ideas that should be helpful. Yeah. Hmm. Do you think that use substitution might work? Do you think there are some sorts of use substitution involved in this problem? Even I'm not sure like what to do because this is the first time seeing this problem. And even I'm trying to think how to approach. Okay, I think maybe like I would just go with some use substitution. Like do you know, like I think if I was the one in the competition, maybe I would just go with some use substitutions because like those tend to be helpful. Even though I'm not sure exactly, but yeah. Okay, I think I saw something over here that can be helpful to us. Hmm. Okay, let us see it this way. So 2, 1 plus 2 log x, right? Then there's this log x, right? So now this can be written as x 1 plus log of x square, right? And now, uh, okay, so log of what I can do is I can write it as half of log of x square. Will that be any way helpful to me? No way. I don't know. I don't know. Hmm. So what should we do now, guys? Oh, okay. Yeah, let us just go with some new substitution and let's see if we can make any progress. I don't see any other ways though. Right? Yeah, so let's go with some new substitutions now. Now if we try to substitute u as log x over here, right? So what we will get is 2 times x will just be e to the power u 1 plus 2u log of u, and dx is just again e to the power u du. Now that's 2 times e to the power 2u log u. Guys, this is no way helpful, I guess. Guys, we are stuck over here. E to the power 2u log u 1 plus 2. Now, how is that even helpful? Guys, I think we should see the answer first and then we can approach this. Do you think I should see the answer first and then approach it? What do you say? Guys, okay, like, do you want me to see the answer? Or I mean, we can see the definitely see the answer first. Like, okay, let us see the answer first. Try no answer. Okay. Okay, let's see if we can make progress. There's this X term involved. That's complicating the problem actually. Hmm. Okay, let us just try to see. Okay, let us do one thing. Let us just try to see if y is log of x square, how this differentiates. Okay, so dy by dx would just be 1 by log of x square times, again 1 by, no, this is not going to work. Okay, wait, let's do it this way. If y is log of x times log of x, will this work? I don't really see a way over here, like how I should proceed. Guys, we need to see the answer first, I guess. I would have tried if I was alone, but like I'm on a live video, so I cannot really make you wait, right? Wow, the answer is simply wow. How do I even approach to get this answer? Mm, 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 mm. Okay, I think one of the ways is to make a use of substitution with log x. I think that's the way. Like, there's no other way to get this. Because if I make use of substitution as log x, I'll get okay. So let's do that. That's the yeah. Let's go with u equals log x. I think that should work. If we make u is equals to log x, right? Or e to the power u will just be x, and e to the power u du will just be dx, right? Now x is just e to the power u half plus, this is just u, and then log of u, and dx is just e to the power u du, right? Now let us try to break this. E to the power 2u times half of log u plus e to the power 2u plus log u plus u du. Now the first one shouldn't be too hard, right? We might have problem with second one. The first one shouldn't be too hard actually, I guess. So let's go to the first one first, and then we'll go with second one as well. So let us say that this one half of e to the power 2u log u. This is our I1, and the second integral of e to the power 2u times u times log u du. This is our I2. Now with the first part, I can just use integration by parts, right? So if I do that, first of all, e to the power 2u, sorry, log u as it is, and then integral of e to the power 2u is just e to the power 2u by 2 minus integral of, now derivative of log u is 1 over u, integral of e to the power 2 is e to the power 2u by 2, right? And that evaluates to 1 over 2 log u e to the, sorry, log u e to the power 2u over 2 Again, now how do I? Again, this one is complicated. This one is a complicated integral. This one needs some special function like exponential integral function, which is again, guys. Okay, let's not deal with this integral for now. Let us see like if there's any way we get some expression from this integral that cancels with this one. Okay, so yeah, let's use that tactic. So I2 is now integral of e to the power 2u log u du, right? So this is just log u e to the power 2u over 4 minus 1 over 4 integral of e to the power 2u by u, right? Okay, and now this becomes, now again if I use integration by parts with our u log u just being our the first part, and this is our second part e to the power 2u by 2, right? Minus integral of, now this just becomes u times 1 by u plus log u, right? And then e to the power 2u by 2 du, right? And yeah, I'm just doing integration by parts. So u log u and e to the power 2u by 2 minus, that's just 1 plus log u e to the power 2u by 2 du. Again after that, u log u e to the power 2u by 2 minus, that's just integral of e to the power 2u over 2. Is that real? Yeah, that is du, and then minus integral of half log u e to the power 2u du. Okay, now notice that, now notice that in while simplifying the I2, this expression that we got, negative of half log u e to the power 2u du, this is just I1, right? So yeah, so now what we got is this I2 already has negative I1, right? So okay, so what I'm trying to say is this is just u log u e to the power 2u by 2 minus e to the power 2u by 4 minus, this is negative I1, right? This entire expression. So I can just take it to other side now. So I1 plus I2 will just be u log u e to the power 2u by 2 minus e to the power 2u by 4. In I1 plus I2 is exactly what we need, right? Our answer was just I1 plus I2, right? So that's our answer. So we got the answer. Now the substitute, now plus C. Now again, so the substitute u as log x and we get the answer. So we did it, right? Okay. Thanks to Suzel, like shout out to Suzel for suggesting u equals log x, right? Log of x e to the power 2 times log of x, that means just x square over 2 minus x square over 4 plus c. Phew, that was something really long. And like, yeah, this was kind of a discovery based problem, right? You just had to figure things out yourself. Let's take the answer. X square log x by 2 minus x square by 4. Yeah, that's it. That was a good problem, right, guys? What do you think? Was that a good problem? Yeah, that was. And yeah, thanks for sending all the emojis. Okay, now let's go to the next problem. Guys, thank you for sending the emojis. I appreciate that. Next one. Woohoo! The next one is even more nicer. Cos to the power 4x minus 1 by sine to the power 8x dx. Okay, let's do it. Question 10. Integral of cos to the power 4x minus 1 by sine to the power 8x dx. Cos to the power 4x minus 1 by sine to the power 8x dx. Right? Okay, now again, how should we approach this problem? This looks complicated, right? How do you think we should be approaching this problem? I think we can use cos to a formula. Yes, we can do that. But will that be helpful for us? Especially because sine to the power 8x, that's a big, not big power. Hmm. 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 Okay, look, do you think that we should just break the numerator and then, sorry, do you think we should just break the numerator and then use the formula? Will that be? I mean, I'm actually afraid with this numerator, sine to the power 8x, which is too big. What's what should we do? Okay, yeah, I think let us do what you are saying. I think that should help us. Yeah, break, and do you want a break? Like, yeah, you can definitely take a break. Like, I mean, okay, let's apply the formula. Cos square x minus 1, cos square x plus 1. Okay, now if we do this, we know that 1 minus cos square x is just negative sine square x, right? And one, and like 1 plus cos square x, what do we do for that? 1 plus cos square x. Cos square x plus 1 by sine to the power 8x dx. Now this just becomes negative of cos square x plus 1 by sine to the power 6x dx. Now what? I mean, how do you get the two cos to a formula actually? No. How do we proceed? How do we proceed? How do we do this, guys? Hey, my boy, Suzal, like, give me some idea. From starting. Okay, like, what do you mean by from starting? I don't get it. Can you be more specific? Like, hmm. I'm doing a YouTube live right now. 10. Okay, guys. Okay, so suggest me some ideas for this problem. Okay, what do I do? Let me think on myself, bro. Yeah. Mm, okay, what should I be doing in this problem? From starting, divide numerator denominator by cos to the power 8. 290% look like it is close 10. Yeah, exactly. From starting, divide numerator by cos to the power 8 x and put as cos to t. That might help. Okay. Is there any difference between doing that from starting and from now? Let me just do it from now. I mean, I can do it from now as well, right? Okay, so do you want me to basically divide by cos to the power 6x, right? Hmm. Okay, is that helpful? If I divide cos to the power 6x, what I get is negative of. I mean, that will be cos to the power negative 4x, right? Which means that will be sec to the power 4x plus that will be 6 to the sec to the power 6x by, is there any difference between it from beginning? No, I think they're same. Yeah. And then this there will be tan to the power 6x. Oh, maybe that simplifies, I guess. Yeah, I think that does. Okay, let's go with his approach, guys. I think his approach should work. Let's go with the approach of Muhammad. Okay, so let's divide by tan to the power 6x. And so this becomes basically, sorry, let's divide by cos to the power 6x. So this becomes sec to the power 4x plus sec to the power 6x by tan to the power 6x dx. Now what I can do is I can basically take sec square x common, right? So this is sec square x plus sec to the power 4x times sec square x dx by tan to the power 6x, right? Now we know that sec square x is basically 1 plus tan square x, right? So what I can do is, if I let y is equals to tan x, so integral of negative of sec square x is just 1 plus y square, and this is just 1 plus y square whole square, right? Because this is the square of sec square x, and now that's just dy. Denominator is y to the power 6. So we have integral of negative of 1 plus y square plus 1 plus 2y square plus y to the power 4 by y to the power 6 dy. So that becomes negative of the integral of 2 plus 3y square plus y to the power 4 by y to the power 6. So it seems like Muhammad's approach is working, right? So this is now uh, 2y to the power negative 5 by negative 5 plus 3 y to the power that's negative 4. So negative 3 by negative 3 plus that's negative 2. So negative 1 by negative 1, right? And so now we finally have 2 by 5y to the power 5 plus 3. Okay, so that's just 1 by y cube. That's just plus 1 by y plus c, right? And now our y is just tan x, right? So using that, we have 2 by 5 tan to the power 5x plus 1 by tan cube x plus 1 by tan x plus c. That's interesting. We can change it to cot, but there's no need. Let us see if it's the right solution or not. It seems like this is the right solution, but even though their answer might be different, I'm not sure. Oh, it's the same. Is it same? I think it is. So okay. Let us try to take our answer to their form. Okay, so just to make sure that we are right, let us change the form of our answer. So basically, we have cot to the power 5x, right, plus cot cube x plus cot x plus c, right? What I can do is 2 by 5 cot x common, right? Do I need to have common? Was 1 we have common? Okay. Let me just take 1 by 5 common. Let me just take 1 by 5 cot x common, right? And then this becomes 2 cot to the power 4x, right? Plus, if I take 1 by 5 cot x common, now there should be 5 cot cube x, there should be 5 cot x, right? Plus c. Yeah, that's how the answer is, right? 1 by 5 cot x. Yeah. So now, this is just cot x over 5. Now 2 times, we know that cosec square x minus cot square x is 1. So cot square x is just cosec square x minus 1 square. Oh, I'm sorry, I made a mistake over here. This is just x square, and there's no cot x now. I'm sorry for that. This is actually cot square, right? I'm sorry, guys. And 5, this is just cosec square x minus 1 plus 5, right? Plus c. Now this becomes cot x over 5 2 times. This is just cosec to the power 4x minus 2 cosec square x plus 1 plus 5 cosec square x minus 5 plus 5 plus c. And this becomes cot x over 5. This is 2 cosec to the power 4x, right? These two cancel out. And there's a negative 4 cosec square x plus 5 cosec square x, so that's just cosec square x. And there's a plus 2 plus c. So that's our answer. Let's see if now it's matches or not. The cot x by 5, 2 cosec to the power 4x cosec square x plus 2. That's the answer. Now it exactly matches, right? Yeah, so we are finally confirmed, I mean sure that the answer is right. And all thanks to Muhammad. Okay, let's go to the next problem now. Next problem is, guys, like, is everyone clear about the solution, like how this worked? I think you can let me know if there's a doubt. I can answer that, but hopefully this wasn't too hard. Actually, just make a tan x substitution, right? Okay, let's go to the next problem now. There are really good problems, right? And I made the integration in the first round. And yeah, there are even more better problems in second, third, and fourth round. Okay. So square root of x plus square root of x square minus 1 dx. This shouldn't be too hard. This shouldn't be too hard. This is the problem 11, right? 11. Okay. The square root of, what was it? X plus square root of x square minus 1. X plus square root of x square minus 1 dx. Okay. Okay, how do you approach this problem, guys? Do you think the substitution should work, or what do you say? Guys, what do you say? Just say something like, do you think they should go with substitution, or like just a trigger substitution, or what? Hey, anyone? Do you think I should go with some trig substitution? Okay, let me do trig substitution, I guess. Right? Okay, no one's responding, so yeah, let me go with it. If I substitute x as sec x, right? If I substitute x as sec x, sorry, sec theta, what happens is dx will just be sec theta tan theta d theta, right? And now integral becomes sec theta plus, now it's sec square x minus 1, which is tan square x, so again square root is tan x, times sec theta tan theta d theta. Oh yeah, laugher, it does look like trigonometry from class 10, right? Okay, now how do I deal with sec theta plus, sorry, it's not tan x, it's tan theta, I'm sorry. Now how do I deal with sec theta plus tan theta, guys? How do I deal with that? I think it will be helpful if I just break it down to sine and cos now, right? We do that. 1 plus cos theta plus sine theta by cos theta times, now this is also sine theta by cos square theta, right? That doesn't really help us, but actually let me write it. Sine theta cos square theta d theta. And oh guys, wait, I need to charge my laptop. Just a second, guys. Just Just 10 seconds. Wait. Hmm. Just a few seconds. And done. Yeah. Okay. So now I can write this as 1 plus sine theta over square root of cos theta. The thing that makes this problem a little bit troublesome is the fact that there are these things. You know what? Instead of sec theta, I think that I should use hyperbolic functions. That would give us some simpler terms over here. Guys, let's do that. Let's use hyperbolic functions. That would give us some simpler terms, right? Let's do that. Okay, if I now use x as cosine theta, right? My dx will just be sine as theta d theta. And also, we know that cosine square theta minus sine square theta is 1, right? So using that, integral becomes, now it just becomes x will just be cosine theta plus square root of cosine square x theta minus 1 is just sine theta, and then dx will just be cosine theta d theta, right? Now what do I do again? Okay, now I can break cosine theta as cosine square theta by 2 plus sine square theta by 2, right? And sine theta is just 2 sine theta by 2 cosine theta by 2, right? And this is just cosine theta d theta outside. Oh, sorry, this is sine theta. I'm sorry. Sorry, guys. This is sine theta d theta outside. Sine theta d theta outside. Okay. Now looks like there's a complete sum over here. This is just cosine theta by 2 plus sine theta by 2 square sine theta d theta, right? So this just becomes integral of cosine theta by 2 plus sine theta by 2 times sine theta d theta, right? Now what do I do next? What do I do next, guys? Now this does seem to be a bit complicated, I guess. I'm just now. Okay, is there like product to sum formula also for hyperbolic functions? If there is, we can use that, right? Let me just Google it. I'm not sure. Wait. Let me just Google it. Uh, product to sum formula. There should be, because every formula is like corresponding to trigonometric product to sum formulas of hyperbolic functions. Yeah, there is. Okay, if it's 2 sin x cos as 2 sin x cos s y, it's the same. Okay, the only difference is in the formula of sin x sin y, the product of the two sines. And yeah, only when there's product of two signs, there's a negative sign involved in the formula, like the entire formula gets a negative sign, except that all the formulas are same. Yeah, so we are safe to use the formulas, guys. So only when there are product of two signs, the entire formula gets a negative sign, right? Otherwise, it's the same. So yeah, we can use the formula, and now this is gonna be simplified. Cosine theta by 2 sin as theta plus sin as theta by 2 sin as theta d theta. This is the same, right? This will just be, let me just see this as the first term, this as second term, so that I can write it as sine of a plus b plus sine of a minus b, right? Yeah. And then plus, now over here, usually there's cos of a minus b in front, but because this is hyperbolic, we will just like multiply the entire expression by negative. So this will basically be cos, this is sin s, sorry. So this is cos s, so first of all there will be plus, and then there will be minus, right? Cos s of, yeah, there's a negative sign, right? Yeah, there is. Because if there are two cosines, in that case it's plus. If there are two signs, there's negative sign. Yeah. Okay. So we are done. No, we are not done. We still have to integrate this. So this is sinus 3 theta by 2 plus sinus theta by 2 plus cos as 3 theta by 2 minus cos as theta by 2 with d theta, right? So this becomes negative cos as 3 theta by 2 divided by 3, sorry, divided by 3 by 2 plus, oh, there's no negative sign actually in hyperbolic. Hyperbolic is so easy, we don't need negative sign. So cos as theta by 2 by 1 over 2 plus sin as 3 theta by 2 plus 3 by 2 minus sin as theta by 2 by 1 over 2 plus c. So that should be the answer. So 2 by 3 of cos as 3 theta by 2 plus sin as 3 theta by 2, right? And 2 times cos as theta by 2 minus sin as theta by 2. And as you guys might know, there's actually a formula that cos as theta plus sin as theta, because this is just e to the power theta plus e to the power minus theta by 2, and then this is just e to the power theta minus e to the power minus theta by 2. If we add this up, this just becomes e to the power theta, right? Similarly, if we subtract these two, this just becomes e to the power negative theta. That's an interesting observation, right? Yeah, so let's use that. So this becomes 2 over 3 e to the power 3 theta by 2, right? Plus 2 times e to the power minus theta over 2 plus c. So that's the answer. 2 e to the power 3 theta by 2 by 3 plus 2 e to the power minus theta by 2 plus c. That's a pretty good answer, guys. Did you like this problem? This was good. This was really good. I loved it. I love the fact that we got some new insights, right? We got the new ideas about the product to sum formulas of hyperbolic functions. Yeah. Yeah. Thank you guys for so much emoji. I really appreciate that. I really appreciate that. Yeah. Guys, do you have anything to ask in this problem? Like any doubts or any queries or anything that you didn't understand? This formula is same, just that there's a negative sign involved, because all the formulas are actually same except the ones where there is product of signs. And since this formula had product of signs while converting, I should just multiply the like trig formula with negative sign. So yeah, you can just Google this up if you are having confusion. You can just Google that product to sum conversion of hyperbolic trig, and yeah, Google will give you the answer. That's what I did. Okay. So yeah, let's go with next problem now. Suzal, thumbs up. So should I go to next problem? Hey Suzal. Oh wait. Oh wait. The answer is different. I think we still need to make some like changes, I guess. Right? I think we still need to make some changes. The fact that the initially it was in terms of x, right? So we need to do that. So now theta is actually cosine inverse x, right? So let's do that. So that means I need to go over here again. I need to go over here again, I guess. Right? And then use the fact that x was cosine theta. I need to go over there again. Woo, this is complicated. How do I even go back? Guys, that's so hard. Okay, guys, this time, what we will do is we will not uh, we will not follow the same answer. What we will do is, what we can do is like 2 over 3 e to the power 3 by 2. Theta is just cosine inverse x, right? Plus 2 times e to the power negative 1 by 2 cosine inverse x plus c, and that's our answer. There's no need to follow the trend, I guess. Guys, are you satisfied? Are you satisfied with this? Huh, guys, are you satisfied with this answer? Yeah, okay. Yeah, I got some lob reactions, so that means yes. So yeah, this answer is satisfying, and if you want, you can definitely change this answer to the like form that's given, right? You can definitely do that. But yeah, this is still an answer, right? This is still in terms of the functions that we know. So yeah, let's go to next problem now. Okay, wow, this is interesting. X cube minus x by x to the power 6 minus 1 dx. 12. Integral of x cube minus x divided by x to the power 6 minus 1 dx. X to the power 6 minus 1 dx. Okay. Now, how do we approach this problem? Okay, first of all, I think one of the easy thing that you can do is basically we can take x common. This becomes x square minus 1. We can also make it as x square cube minus 1 dx. That's pretty obvious. Let's do that first. So this becomes x times x square minus 1, and this becomes a minus b, a square plus ab plus b square, right? This is just the formula of a cube minus b cube, that it's a minus b, a square plus ab plus b square, right? That's pretty obvious, right, guys? And now we can cancel this out. So this becomes x over, guys, but will this help me solve the problem in this way? Do you think I'm taking the right way? Okay, maybe I am, doesn't matter. Okay, so x to the power 4 plus x square plus 1 dx. Now if you make a substitution that y is x square, dy will just be 2x dx. So that means dy over 2 will just be x dx, right? Now using that, this will be integral of dy over 2 by, well, oh, now yeah, I'm taking the right way. And now if I just make half dy by y square plus y plus 1, now you can complete this square, right, guys? So this becomes half of integral dy by y square plus y plus 1 over 4 minus 1 over 4 plus 1. And the reason I did this is, I guess you guys know the reason why I did this, right? If you have taken some calc classes, because the reason is this now becomes 1 plus half square, and this becomes root 3 by 2 square, right? And so now this is just 1 by 2, and then 1 by a tan inverse x by a, right? Plus c. And so this becomes 1 by root 3 tan inverse of 2i plus 1 over root 3, right? And what was our y? Our y was x square. So 1 over root 3 tan inverse 2x square plus 1 by root 3. This problem was pretty easy compared to others. Right, guys? Yeah. Thanks for sending the lobs and then other emojis. So, yeah. 1 by root 3 tan inverse 2x square plus 1 by root 3. Yeah, this one was too easy. This one was too easy actually. Woo! This is also really easy. There's just some. I actually know the direct formula for this one, right? Like, and because I wanna like recommend you guys to know the direct formula for this one, I'm not going to solve it, guys. You guys just there's some way you can just use tricks, or you can just again use maybe x as sec theta or cos as theta and then get the answer, right? But I'm going to do it directly, and then I recommend you guys to do it the same thing, right? The direct formula for this is for x square minus a square. The direct formula is x by 2 square root of x square minus a square, and then plus a square by 2 ln of x plus square root of x square minus a square plus c. That's direct formula. Please know this formula. Similarly, there's also formula for x square plus a square. It's almost the same. X by 2 square root of x square plus a square by 2 ln of x plus square root of x square plus a square. I'm just trying to flex my skill, flex my knowledge, right? The last one is a square minus x square dx, and that's just x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a plus c. It's helpful to know this formula, and you can flex with others just like how I did with you, right? So this becomes x by 2 square root of x square minus 1 plus a square by 2 ln of x plus square root of x square minus 1 plus c. Even though you don't really need to know the formula, but for integration b, if you know the formula, like you can be quick, right? You can solve it faster, and that's what one of the goals of integration b is, right? To be able to solve faster. Yeah. So guys, and also 6 of you who are watching, you might want to join the membership of my channel so that you get the access to my videos earlier than others, right? If you want, it's just $1, I guess. It's not even $1. Really cheap. Yeah, if you want, you can do that. That's just a promotion. Okay, yeah, guys. It's really cheap. It's around, I don't know, like some cents are of $1. If you want, you can do that. Okay, now let us check the answer. X by 2 is equal to x minus 1 minus 1 by 2. Oh, guys. Sorry, guys. Sorry. Okay. You know what? Like these two formulas have plus sign, but this formula has negative sign. I'm sorry. Guys, know the formula correctly, okay? Like just don't memorize like me. Yeah. The last two formulas definitely have plus sign. I'm pretty confident about that. Oh wow, you're welcome to level 1. Oh, thank you so much, Sudhir. Thank you so much. Yeah. Okay. I'm really grateful to you for doing this. Okay, guys. Now, like definitely the last two formulas have plus sign, but the first formula has a negative sign. Like, do remember that correctly, otherwise you might mess up, just like how I did right now, right? So yeah, and yeah, if you know that, so yeah, now it's because it's plus. Now the answer is correct. 1/2, and then x is equal to x squared minus 1, and then minus log of x plus x square root of x squared minus 1. Yeah, that's correct now. So let's go to next problem now. Wow, this is interesting. Sin x, sin of sin x, sin of cos x plus cos x, cos of sin x, cos of cos x. Woo, that's some good problems. Sin x, sin of cos x, sin of sin x plus cos x, cos of sin x, cos of cos x. Okay, so this need ideas how to solve this problem. Sin of cos, sin of sin plus cos of sin, cos of cos. It looks like it's a really good problem. And yeah, I want your ideas first. Suzal, I would really appreciate. Now, what do you think would be a good approach for this problem? Since there's a sum of product, maybe product rule should be helpful, right? What do you say? Or do you think that new substitutions would be more helpful? Give your ideas. Even I'm not sure how to approach, so I'm asking you guys. Anything that might come to your mind that you think you would use if you were in the actual competition? Hmm? Okay, so let us see how we can solve this problem. Okay, so you might notice that over here, there's the sign of x, right? And okay, sine of cos of x with sine x. So this seems like a chain rule over here, right? And also there's this cos of sine of x times cos x. So that looks like a chain rule. Now we just want to see how we can make use of this fact. Y is equals to cos x, maybe, I don't know. Yeah, we can make that, but if you make a substitution that you are saying y equals to cos x, yeah, like there might be some problem with this expression, right? Cos of sine x. So yeah, I think a good approach would be to make use of the chain rule, to try to observe the chain rule, how that's working over here, and then go accordingly. Yeah. So let's try to do that. Okay. So if you go with that approach, we know that this thing over here is just negative times the derivative of sine of cos x, right? And then now this is just sine of sine x plus over here, this is just the derivative of the cos of sine x, right? And this one is just the cos of cos x, right? Now, is this anywhere helpful for us? Hmm? Do you think that that is anyway helpful for us? Hmm. Even I don't see how to proceed to the next problem. So it seems like we might get stuck in the 14th problem. There are six more to go, guys. Okay, let me see if I copied the problem correctly. Wait, what does it feel like? There's some inconsistency with the problem. Oh, okay. So what I think is now, what I think is this over here, this over here is actually the derivative of cos x, right? This is actually the derivative of cos x. Okay, guys. Okay, there was some problem with the chain rule, so now I think we are getting closer to the solution. So what you can try to like observe is now over here, you can actually introduce negative sign to each of the terms, right, without changing the sign. So notice that now this is just the derivative of the cos of cos x. And the reason this works is, first of all, you just take the derivative of the outer term. So cos x become negative sine of cos x. And then derivative of the cos x is just negative sine x times sine of sine x. And similarly over here, the cos of cos x is as it is, right? And now the next term is just the derivative of sine of sine x, right? Because that just becomes, first of all, derivative of outer term sine gives us cos of sine x and then cos x. So now you might see that this is actually in the form of product rule. So if sine of sine x be u and cos of cos x be b, this other term is just b prime, and this the last term is just u prime. So we have the form of u b prime plus b u prime, and we know that this is just the derivative of the product u b, right? So using this fact, now we can say that this entire expression is just the derivative of cos x times sine of sine x, right? So since we know that the integration is just the opposite of the derivative, so because there's some integral of the derivative, we can just see it like the integral and derivative sign being cancelled, and that gives us our answer: cos of cos x times sine of sine x plus c. So definitely this problem involves some magical thinking. I don't know, because this some problem wasn't really of doing calculations but trying to observe things, right? So yeah, this is how we do it. This was how we do it. We just need to observe some chain rule, product rule, and that solves the problem. So now let's go to our next problem, the 15th problem of MIT integration B, right? And the next one is about log of x divided by x squared dx. And this seems to be a pretty good problem again. Just like the previous one, now we are dividing log x over by x and then square dx. So how would we approach this problem? Do you think that use of substitution will be helpful over here? Because we clearly see that there is the derivative of log x involved along with the log x. And since we have both the function and its derivative, the chain rule should be helpful, right? Sorry, substitution should be helpful, right? What do you say? Oh yeah, exactly, exactly. So you use the substitution that u is log x. Now if we use that substitution, we get du as 1 over x dx, right? So now this is just log square x times 1 by x squared dx, right? And over here, our x is just e to the power u. So what we get is, we will have this as u square. We will have u square, and then we will have 1 over x, which now becomes 1 over e to the power u, right? And the next 1 over x dx will just be du. And now this simplifies a lot. Now this just becomes e to the power negative u times u squared du, right? And now we can solve this using integration by parts, right? So let's use the integration by parts, or also you can use the DI method, right? So let's go with the integration by parts because both of them are same. So this just evaluates to, first of all, u square as it is, and the integral of e to the power negative u is just e to the power negative u divided by negative 1, right? Minus integral of, now derivative of u square is just 2u, integral of e to the power negative u is just e to the power negative u by negative 1 du, right? So now this evaluates to again negative of u square e to the power negative u plus 2 times integral of u e to the power negative u du, right? Now again use the integration by parts, and that will give us our answer. Plus 2 times, now this is just u times e to the power negative u by negative 1 minus integral of 1 times e to the power negative u by negative 1 du. Okay, now after this is just negative u square to the power negative u, and then there's again negative sign involved, 2u to the power negative u, right? And now there's a plus sign, right? But again, also notice that there's also a 2 over here because this 2 actually multiplies the both expression, right? And now if we integrate e to the power negative u, you will get another negative sign by the integration, and then plus c. So that's supposed to be our answer. And now we again need to go back to the world of x from the world of u, right? Because that's where we started. And we know that u is just log x. So this becomes negative of log square x, right? And that's again now e to the power negative log x is just 1 by x, right? Minus 2 times log x times 1 over x minus 2 times 1 over x, and that's supposed to be our answer. But before that, let us just take negative 2 by x common, right? So if we take negative 2 by x common, we will get log square x over 2 plus log x plus 1 plus c. So let's take our answer. Negative 2 over x, and then negative 2 over x. That's exactly the answer, right? And right, I think that will look a bit more nicer. So yeah, let's do that just to make it a bit more nicer. So if we do that, we get 2 plus 2 log x plus log square x divided by x plus c. And yeah, that's exactly the answer in the way it's presented over here. Negative times 2 plus 2 log x plus log square x over x d, yeah, plus c. Okay, that was a good problem, and it just involved some use substitution, right? So whenever you notice a derivative and a function, you might just want to do a use substitution, and yeah, that easily works. That was the easy problem, right, guys? Yeah, exactly. It was a really easy problem. So now let's go to the next problem. Integral of sine square 2x e to the power 2x dx. Okay, guys. So we have integral of, now this is our problem 16, integral of sine square 2x e to the power 2x dx. Okay, guys. How will you approach this problem? Okay, give me some ways, guys. Sujal, do you have any ideas? Or also Lafer, Muhammad, and a few other guys? Okito. What do you think I should do? What should be my first step, I guess? How do you think I can simplify this problem? y equals to x. Yeah, that definitely helps. But after that, like that's not a big step, right? That's the simple simply. Yeah, I agree that simplifies. But like what after that? Like yeah, let's assume we did that. Now after that, hmm. Okay, this like takes me back to the high school days where we had this integral formula, right? E to the power ax, let's say sine bx dx. So using integration by parts, we got the formula for this integral to be 1 by a square plus b square, right? And then e to the power ax. And what was the next? Was it cos bx? Let me just go Google it because I don't really want to mess it up. Integral of e to the power ax sine bx dx. Okay, so the formula is a sine bx. So e to the power a square plus b square, right? Also there's e to the power ax term over here. And then that's a sine bx minus b cos bx, right? We had this formula. I think we are going to need this formula over here as well. Similarly, we had another formula, e to the power ax cos bx dx, and its integral was, again, you can use integration by parts to get this formula, right? E to the power ax by a square plus b square, and that's a cos bx plus b sine bx. So I think this formula are gonna be helpful. And how do you think we can use this formula in this case? Oh, yeah, we can definitely do integration by parts, but I think there's a shortcut. Like, what you can do is, if you just try to change sine square to x as 1 minus cos 4x by 2, you will easily get the solution. Now, this will just be half of integral of e to the power 2x minus cos of 4x e to the power 2x dx, right? Now, if we integrate it, this will just be half times e to the power 2x over 2, right? And then negative of, now we know the formula for this expression, right? That's just e to the power 2x by 2 square plus 4 square, right? Just as in the formula, we are going to use the second formula, right? And then a is 2 in this case, 2 cos 4x plus 4 sine 4x, right? Plus c, and that's the answer. So that's really quick, right? E to the power 2x by 4 minus e to the power 2x over this is 16 plus 4 is 20 times 2 is 40, right? And then 2 cos 4x plus 4 sine 4x plus c. Yeah, and that's the answer. So yeah, that's how it made our life a lot easier, right? You should just take the answer first. Okay, so first of all, let me take e to the power 2x by 2x common. Yeah, and then we will see. If you take e to the power 2x common now, 1 by 4 minus 1 by 20 times cos 4x, again minus 1 by 10 times sine 4x plus c, right? E to the power 2x, and then 1 by 4 minus 1 by 10 times sine 4x minus 1 by 10 cos 4x. Yeah, that's exactly the answer. So Suzal, did you see like how it was simplified? Actually, the thing is we are definitely doing integration by parts here as well, but because we have formula, it's already done. We just need to apply formula now. So do you see how it was helpful? Yeah, you remember the formula from Great to Well, right? Yeah, we learned this formula. Yeah, exactly, exactly. So 17. There are three more to go, guys, and we will be done with the amateur integration B 2025 regular season. Woo! This one is interesting. So 17 number. Integral from 0 to 7 over 2, and then square root of x plus 1 over square root of x plus 1 over. Wow, I love this. I love this. Square root of x plus 1 over square root of x plus 1 over square root of x plus 1 over and goes in dx. Wow, that's such an interesting problem. How will you approach this, guys? Again, how will you approach this? There seems to be an infinitely infinitely long function, right? How, what would be your approach, guys? Like, how do you think we can simplify this infinite function to a function that we can actually integrate? Because this no way seems like it's integrable, right? Just leave your ideas, just drop your ideas. Like, yeah. There is some way like we can reduce this infinite function to a finite function so that we can actually integrate. Just think, just yeah. Like, anything, anything like Suzel, Lafer, Muhammad, and Okito, and others. Okay, seems like there are no ideas this time. Oh, okay. Let's say the function is y. So yeah, exactly. This is the way. This is the way that I knew. Yeah, and this works. Okay, so let's go with the way that Muhammad Sahid suggested us, right? Okay, so what you can do is we can basically just assume that this function first of all is a function in like function y, right? So now if we do that, this is going to infinity, right? If we do that, notice that over here this function is again y, right? Because y function basically had square root of x plus 1 over square root of x plus 1 over square root of, yeah. And again, if we just terminate the like the upper person, again this thing over here is again the same, right? Square root of x plus 1 over square root of 1 plus x, yeah. So because both of them are going to infinity, they are basically same. And now we can try to solve for y. You see how we are trying to proceed ahead. Yeah, okay. So now this becomes y square is equals to x plus 1 over y, right? Okay, now after that, okay, so let's say the function is y, so that x plus 1 over y is y square, solve for y and put it back into the equation. Okay, yeah. So we're going to do that. Now this becomes y cube is equals to x. Okay, now after that, let's say the function is y, so that x plus 1 over y is y square, solve for y and put it back into the equation. Okay, yeah. So we're going to do that. Now this becomes y cube is equals to x. Okay, now this becomes y square, solve for y and put it back into the equation. Okay, yeah. y plus 1, and then y cube minus xy minus 1 is equals to 0, right? Now, how to solve for y again? Because now, how will you solve for y? This seems to be a cubic function, right? Now we need a cubic formula. And there is a cubic formula actually, right? And we are gonna use that. And there actually the actual cubic formula is too long, but in our case, even the shorter one would work, right? Let me just Google the simpler cubic formula first, and then yeah, and then we'll solve the problem. Simpler cubic formula where b is 0. Let me just ask the Google AI, sorry, the Bard simpler cubic formula where b is equals to 0. Yeah, okay, that actually turns out to be really easy, right? Or is it just okay, yeah, I did get a formula, but it seems like it's more easier than it should be. Just a second, guys. Let me actually get the real formula for this cubic equation, and then we can solve it.